Everybody, welcome back. We are to the last chapter in business calculus. We're to section 4.1. This is a relatively short section, but it is an important one for what we're doing for the rest of the semester. We are now going to be dealing with multivariable functions. So this is going to be a new thing. I'm not going to get too much into the wording here. However, I do want to talk about, instead of y equals f of x, which is what we're used to, where x is the domain and y is the range, we now have two variables that represent the domain. Meaning we end up with z is a function of x and y. Now, this does go larger. We could have w equals a function of x, y, and z, and so on. We can make it as big or small as we need to make it. But we're going to just stick with two variables as far as the domain goes and one range variable. And I just want to jump into it. So we are going to evaluate this function at f of 3, 5, meaning when x equals 3 and y equals 5. And we'll get an decimal approximation for that. So let's see, 3 raised to the 4th power times the square root of 5. So this is about 181.12. Now, just to be clear, the 3 and the 5 are the domain. And this is the range, meaning the y value, or in our case, the z value. And so our next one is going to be f of 5, 3. Oops. Let's draw a line there, separate that out. 5, 3. This is the square root of 175 minus 4 times 5 squared minus 3 times 3 squared. Let's see what we get with all of that. So we have the square root of 175 minus 4 times 25 minus 3 times 9. And we're getting about 6.9282. Should probably highlight these as our answers. I know I'm a little erratic. First one I rounded off to 2 decimal places. This one I'm rounding off to 4. It doesn't really specify, so it doesn't really matter. All right, our last one, we have kind of a long one here. F of 8, 2. This will be 100 times 8 plus 60 times 2 minus 2 times 8 squared minus 5 times 2 squared minus 8 times 2. Let's see what we get with that. So 100 times 8 plus 60 times 2 minus 2 times 8 squared minus 5 times 2 squared minus 8 times 2. And I'm getting about 756. So it's a new thing, more than one variable. It's a little weird. In 2 dimensions, when we're graphing, we have our x and our y. In 3 dimensions, we are all over the place. We have, let me blow this out a little bit so we can kind of analyze this with 3 space. I want to point out that our point here is x, y, and z. And you can see it's in 3 space. Here on the y-axis, oops, both x and z are 0. And on the x-axis, both y and z are 0. And on the z-axis, both x and y are 0. And that brings us to our nice picture here. So we have the point 4, 2, 3, meaning x equals 4, y equals 2, z equals 3. And we can see we have some of our points sort of highlighted. And I want to write out a couple of other points that are here. This is 0 to 0. This is 4, 0, 0. And this is at 0, 0, 3. So just getting us an idea of what three-dimensional graphs look like. In third semester calculus, in the regular calculus, we deal a lot more with 3 dimensions. In fact, most of the semester is 3-dimensional. And it's a little overwhelming, even for my advanced engineering students. It can become very overwhelming. So let's talk about some things we can do in 3 space. So if we have 2 points, x1, y1, z1, and the other one is x2, y2, z2, the distance between them, and we have our typical distance formula. This is nothing new here. And you can see it's a variation on the Pythagorean theorem. I'm not going to derive it too much. Now, when that equals a constant, meaning all that square root and all that equals exactly a constant, what we end up with is a sphere with the equation x minus a, meaning a is the x coordinate of the center squared, plus y minus b squared, where b is the y coordinate of the center, plus z minus c squared, where c is the z coordinate of the center, equals r squared. R is the radius, meaning the distance from the center to any point on the sphere. And you can see we have the same formula here. So they want us to write an equation for a sphere centered at the point. Now, notice in the formula, it's x minus a, y minus b, z minus c. So that means all the signs change. So y plus x plus 7 squared plus y plus 8 squared plus y plus 4 squared, because they're all negative, equals 5 squared, which is 25, because it's r squared. And that is our sphere. All right, so we are now to some business applications. The demand functions for 2 products are given below. And these are all in prices for dollars. So for Q sub 1 is our first demand function is 700 minus 5 times P sub 1 plus 2 times P sub 2. Our second demand function, Q sub 2, is 1200 plus 5 P sub 1 minus 2 P sub 2. And what is the quantity demanded for each when the price product for product 1 is 30 and product 2 is 10? So I'm going to bring this over here. So Q sub 1 of 30, 10 is going to be 700 minus 5 times 30 plus 2 times 10. Let's see what we get. 700 minus 5 times 30 plus 2 times 10. So I'm getting 570. Q sub 2, come on. Q sub 2, when P sub 1 is 30 and P sub 2 is 10, we are getting 1200 plus 5 times 30 minus 2 times 10. So I'm getting 1330, 1,330 items. All right, so the next part has a bit of an explanation. It says, are these 2 products complementary goods or substitute goods? So let's throw down a definition for these as we do this. So 2 goods are complementary if an increase in the price of either decreases the demand for both. And two goods. So here's our first definition. Second definition, two goods are a substitute if an increase in the price of either increases the demand or the other. So what we're going to do is I'm going to set the two equal to each other. I'm going to do that up here. 700 minus 5p sub 1 plus 2p sub 2 equals 1200 plus 5p sub 1 minus 2p sub 2. And I'm going to get p sub 1 by itself. I'm going to subtract the 5p sub 1 from the right to the left, so I get negative 10p sub 1. I'm going to move the 700 and the 2p sub 2 to the other side. That's going to give me 500 minus 4p sub 2, which means p sub 1, when I divide by negative 10, is going to give me 2 over 5 p sub 2 minus 50. And because the slope is positive, that means as one does well, the other also does well. So in this case, they are substitute. By the definition that we have there. The last part, we have a Cobbs-Douglas production function. So P of LK is 18L to the 0.5 times K to the 0.5. Find the total units when L is 10 and K is 18. So we're going to get 18 times 10 to the 1/2 power times 18 to the 1/2 power. And we're going to go to 3 decimal places. Let's use the arrow to get out of the exponent if you need to. Times 18 raised to the 0.5. So I'm getting about 241.495 units. So it's not too bad.